This video is about chapter 16.1, reflection of light, and chapter 16.2, plane mirrors. Our objective is to describe the basic properties of reflection and analyze plane mirrors. The basics of light. Reflection occurs at boundaries. A boundary is can be explained as follows. Okay, so in this diagram we have a boundary between air and water. So this is supposed to be the surface of the water. We've got air and then water. So air gives less resistance to light, water gives more resistance to light. Because of this difference, it allows light to be reflected. So a light ray comes in and then it reflects off the water. So this is what it means by reflection occurs at boundaries. Another example could be between air and if we have something solid like a mirror or a mirror, then reflection can also occur there. None of the questions in this video are about this topic, but just so that you understand what that sentence refers to. Then we read waves such as light, sound, electromagnetic waves bounce or reflect off the boundary. So here we can see what reflection looks like. Light travels in straight lines. When we draw diagrams with light rays in, we always use straight lines, so it's important to have a ruler when you draw your diagrams, and light can be represented as a wavefront or a ray. We will look at this point at the very end. Just briefly, a ray is a straight line with an arrow to indicate the direction in which the ray is going, and then a wavefront we'll look at the end. Okay, the law of reflection. The angle of reflection is equal to the angle of incidence, or theta r equals theta I. I'm not sure if you can see that. Let me zoom in slightly. It might be a little bit more clear. Otherwise you can just look at the PowerPoint, theta r, theta I. And in this diagram we can see we have a light going toward the mirror on the left, and we have an angle between something called the normal and the plane. So we'll say that this is our surface. We could also draw this at slightly a different angle. Okay, so this line, the dotted line, would be our normal. And then we have a ray coming in like that. See if it can touch the point. And a ray going out like that. Right. Let's rather use a different color. Okay, so this angle here is the angle of incidence, and then this angle here is called the angle of reflection. So between the horizontal surface where reflection occurs, so in this case at the mirror, the normal is always at 90 degrees to the surface. On both sides. So on this side we'd also have 90 degrees, and that is the definition of the normal. It's an imaginary line, a dotted line, and we use it to calculate the angle of incidence and reflection. So the angle of incidence is between the incoming ray and the normal. Okay, so this angle right here, and the angle of reflection is between the reflected ray and the normal, and these two are always the same. We'll explore this further in different questions, but that is basically what this diagram represents, just at a different angle. Okay, next we get two types of reflection, something called specular reflection and diffuse reflection. So specular reflection occurs when light reflects off a smooth surface, and this gives a clear and sharp image. For example, a mirror is a smooth surface, or like a very smooth metal, any surface that is nice and smooth. Diffuse reflection occurs when light reflects off a rough or a bumpy surface. Images are less clear. Most non-shiny surfaces are diffuse due to rough, bumpy surfaces at a microscopic scale. Example, a page. And this is what the reflection looks like, and that's why the image won't be clear. Okay, so we get to our first question, question 2. Analyze a beam of light. Analyze. A beam of light reflects from a mirror, as shown in figure 16.11. That's this one. If the angle of incidence of the beam is increased, does the reflected beam shift in direction 1, direction 2, or stay in the same direction? Explain. All right. So firstly, we need to understand where is the angle of incidence. Before I answer this question, please write down question 2. Maybe write like that, question 2. Make sure that you've written the title, which was shown at the beginning. And then as you work through the video, please at least reference the question that you'll be answering. There's no need to copy down the question, but at least reference the question, then you know where to go find the answer in the answer manual for studying for the exam later. Okay, so you write question 2. Please pause the video and then see if you can answer this before I explain it. Okay, so like I said before, first we need to know what is the angle of incidence. Okay, so remember the angle of incidence, we look at the incoming ray, we look at the normal, and that will be this angle right here. Okay, so I'll mark it, and what they're saying is if the angle of incidence is increased, okay, so that means this angle is going to be bigger. So if we have a new line, a new ray coming in, maybe the line will be something like that, okay? Then we know that the angle of incidence will always be the angle of reflection, so we'll have an angle of that size, and then this ray should be going, it should be going at about the same angle, so that those two are about the same sizes. Sorry if they're not drawn very accurately, but we can clearly see that if this angle increases, it means that that angle will also increase, and therefore it will move in direction 2. So remember to write your answer direction 2. Okay, we now look at question 3. Which type of surface, smooth or rough, produces clear reflected images? And the answer is smooth. Okay, so remember to write question 3 and then write your answer. Okay, so we saw that the explanation for that was given a little bit earlier over there. Okay, so now we can look at a new question, question 4. We zoom in slightly. Okay, question 4, triple choice. Figure 16.12, this diagram here, shows a horizontal incident beam of light reflecting from a mirror inclined at an angle theta above a horizontal. Okay, so we've got a light coming in here, and it's at an angle theta, or the mirror is at an angle theta to the horizontal, and that's the ray coming in. The reflected beam of light makes an angle of, I'm actually not sure what we call this symbol, with the horizontal. If theta is increased, does that increase, decrease, or stay the same? Explain. Okay, so before I give the answer, pause the video and see if you can answer it yourself. Okay, so for this question, please remember to write down question 4 and then answer it. Please practice these questions as you would do them in an exam. Alright, so maybe we'll give you a question with a picture. If the picture is too small, you have to redraw the picture. Okay, so please, before continuing with the question, just redraw this this picture using a ruler and a pencil. If you don't have a ruler, you can draw it freehand. Make sure it's nice and big so that you have enough space to write in the different angles. I'm just going to use the one here to save time. Okay, so there is a rule in math that says if we have two parallel lines, we get a figure like this. Okay, so let's say we have a Z figure, and that line and this line are parallel. All right. If we have the case like that, then this angle here and this angle here is exactly the same angle, and that's just the math rule that you need to know. So if we can use that same rule here, we can see that this dotted line represents the horizontal. So I'm just going to draw an arrow on that, and then this ray is coming in on the horizontal as it said in the question. So I'm going to draw a line on that. So let me just get a highlighter here, and we have our Z figure as indicated there. Okay, so that shows us that if this angle is theta, that angle will also be theta. So they're the same, those two angles. Okay. Okay, so the question says, if theta is increased, so if this angle increases, what happens to that angle right there? So you can see this dotted line looks similar to the one here at the bottom, so it means that that's also representing the horizontal. So that's important when we look at the answer at the end. So we know this angle and that angle is the same. If this angle increases, that angle will increase. That means that the new ray that we have will go, let's make it quite extreme, and it will go, let's say like that. Okay, sorry, if theta, my mistake, if theta increases, okay, that means this angle will increase. Currently it's here, and then that angle will increase and it will get bigger. So let's make it nice and extreme like that. Okay, so the new theta, I'm just going to draw it in pink. That was the new angle, so we can see it increased, and we know that the angle of incidence and angle of reflection needs to be the same, so we'll draw it more or less the same like that. And let's draw these two angles in blue. Okay, so that angle and that angle should be the same, but we can get the idea like this. So if we just extend this dotted line to make it a little bit more clear, we can see that the new angle over here is bigger than the angle we have here. Okay, so the answer is it will increase. Okay, so there's no calculation that you need to write down. A question like this will probably just be 1 mark, and you just have to think it through. Remember to draw your diagram so that you can make some notes like I did, and then you can clearly see that it increases. Okay, so we look at question 5, and we see it says, calculate. Suppose the angle of the mirror relative to the horizontal in figure 16.12 is theta equals 30 degrees. What is the angle of incidence? So they're saying that this angle here is 30, and they want to know what is the angle of incidence. Okay, so like before, write down your question number, reference question 5. You can potentially use the diagram from before, or just redraw the diagram, and then please attempt the question, pause the video, try to answer it yourself, and then I'll give you the answer when you play again. they say that this angle is equal to 30 degrees. That means that that angle is going to be equal to 30 degrees because of the Z rule, which I explained before. They're asking us what is the angle of incidence. So the angle of incidence is this one, between the normal and the incoming ray. And we know that the angle between the normal and the mirror is always 90. So if we know that this total is 90, this is 30, we know that the angle of incidence is going to be equal to 90 minus 30 is going to be equals to 60 degrees. Okay, so that's your answer. Okay, so the next question, question 6. Calculate. Suppose the angle of the mirror relative to the horizontal in this figure is 20 degrees. So here it's 20 instead of 30 like before. What is the angle? I'm just going to call it x. What is the angle x? What angle x does the reflected beam make with the horizontal? Okay, so here we have the horizontal. This light is coming in along the horizontal. This dotted line also represents the horizontal. Okay, so please reference the question, question 6. Please redraw the diagram so that you can make some notes, and then pause the video. Please try and answer it, and then I'll give you the answer after you play again. Okay, so the solution to this question is a little bit tricky. Firstly, we draw the diagram. This is very important. Make sure it's large enough so that when you draw in your angles, it's still very clear. We start here with 20 degrees. Because of that Z rule, we're going to use this twice. This rule that says that this is X and that is X. When we have two parallel lines, we can see that we have two parallel lines in the shape of a Z over here, and we also have another one. I should actually use a different color over here, Z, and then I'm just going to go over the top here, a Z. Okay, and then let's go red color. What angle will we call this? Let's say Y. Okay, let's call this Y, and we'll call this Y. Okay, so we can see there's a Z as well, and that angle has to be equal to that angle because of the math rule. Okay, so we start here with 20 degrees. That means this has to be 20 degrees. Okay, we know that the normal and this makes an angle of 90. 90 minus 20 is equal to 70 degrees. Okay, so this angle here will be equal to 70 degrees, and this is the angle of incidence. The angle of reflection will be the same angle. Let me just use a different color to distinguish. Okay, so this will also be 70 because the angle of incidence and angle of reflection is always the same. We can see here that Y, okay, is going to be equal to 70 plus 70. So that's going to be 140. Okay, so remember Y is the same as Y over here, and I'm just going to write here 140 degrees. Okay, now if we want to find X, there's another math rule that says when we have a straight line, all the angles on a straight line adds up to 180 degrees. So if we have that, we can draw many different angles, A, B, C, D. When we add all of them, A plus B plus C plus D, all of this will equal to 180 degrees. So here we can see 180 degrees. Let me just make it a little bit more clear. Actually, no, I'll just keep that before I erase it. Let's use black. Okay, so that angle right here is angles on a straight line. Okay, so that means that x plus 140 will be equal to 180 degrees, or that gives us that x is going to be equal to 180 minus 140, and that's going to give us x is equal to 40 degrees. Okay, so remember your unit, and this is your answer. Okay, so the next topic or aspect of this lesson we look at is plane mirrors, which will be very similar to the previous section. The objective: describe the basic properties of reflection in plane mirrors. Okay, so plane mirrors produce an upright image, correct side up. That appears to be the same distance from the mirror that you are. It also appears that right and left have been reversed. So think of yourself standing in front of a mirror. If you raise your left hand, then your image in the mirror, the same side is lifted. So I don't even know how I'll represent this on a diagram. So just think about it. Imagine. Imagine that image was a different person. Which hand would they be raising? If you are raising your left hand, that means that your image is raising its right hand. So that's why it says that it appears that the right and left is reversed. So what it said before, the distance is the same. So this is the real thing, and here we have the image. Okay, so that distance will be equal to that distance. It says here that di is equal to negative do. Why is there a negative sign? Because we take everything in a specific direction as positive. So it says here that di is the positive one. So this is the object, this is the image, and the distance to the image is positive. Okay, that means that anything in the opposite direction, so if we take a distance going from here to here in the opposite direction, this has to be negative. Okay, because everything to the right will go like this. Everything to the right is positive. Okay, this section here, everything to the right is positive. So when we go from the mirror to the left, that's why we have that as a negative. Okay, so the height is also the same. Height of the image is the same as the height of the object. Okay, so virtual image. The image behind the mirror is a virtual image. That's this one right here. And what does that mean? It means that light cannot pass through the image, and it cannot be projected onto a screen, but it looks real to your eye. Okay, so like if you look behind the mirror, you can't see it anymore. So that's why we call it virtual. Okay, so conceptual example. How tall is the mirror? The question basically asks, you're standing in front of the mirror, you want to know what is the minimum height that the mirror can be for you to see how tall you are. You can read through the whole reasoning and explanation, but if we ask you a question like this in the exam, the answer is it needs to be half of your height. This could potentially be a 1 mark question. Or we could ask you to give an give an explanation. I highly doubt it, but then you have your reasoning here. You can read through that yourself. Okay, so we look at this guided example, example 16.4. Let me just get the view good. Okay, so two plane mirrors are placed at right angles as shown below. A ray of light comes from the right and reflects from the lower mirror. Okay, a ray of light is coming from the right, it reflects off the lower mirror. The angle this ray makes with the horizontal is 30 degrees. Okay, so here incoming ray, 30 degrees. Find the angle of the outgoing ray that the outgoing ray makes with the horizontal after reflecting once from each mirror. Okay, so it's coming in 30 degrees, it reflects off once, it reflects again, and then we know that this is the horizontal and this is also representing the horizontal. Okay, both of them are in the same plane. So we want to find that angle right there, 90 minus theta. Okay, so to answer this question, you need to redraw the diagram. So imagine in the exam we give you the question, maybe we don't even give you a diagram to illustrate what's happening. From the explanation you need to be able to draw this. So use a ruler, draw your mirrors, and then draw in the rays using a ruler, use a dotted line to draw the normal, and then you add your angles. So we start here 30 degrees. Okay, let's go step by step. If this is 30, that means that that angle will be, let me just get a pen, this angle will be 90 minus 30. Okay, so that'll be 60 degrees. This angle has to be the same as that angle, so this will also be 60 degrees. Okay, if this is 60 degrees, this has to be 30 degrees. Or you could have immediately known that that 30 and that one is the same. This angle is 90 degrees because the question said that the two mirrors are at 90 degrees to each other. We know that the sum or the total of the interior angles in a triangle adds up to 180. Okay, so here we have 90. Let's just write that on here. Okay, so 90 plus 30 plus theta is going to be equal to 180 degrees. Okay, so this angle will then give me 60. Okay, you can work that out. And actually they gave us, after we knew that this theta is 60, we could have known that that is 60. We know that that is 60. We know that this is 90 minus theta. So because we know that theta is equal to 60 degrees, and we are interested in this angle right here, then we know that 90 minus theta, or minus 60 degrees, is going to be equal to 30 degrees. So that is our answer. Let's just quickly check here. Okay, so 90 minus theta, you can rewind the video if you want to see the explanation written. Okay, so the next one, guided example 16.2, reflecting on a flower. You'll see that this is in the PowerPoint on Seesaw, but we won't ask you any question like this, so that's why I drew a large X through it. No need to study this. Okay, so next, let's just zoom in here. Question 11, apply. If an object is 1 meter in front of a plane mirror, how far is the image behind the mirror? Okay, so I advise, even if it's very easy for you, to just draw a very quick image. Okay, so I have a mirror and I have an object. Okay, I'm just going to draw a flat line here so I know where I can draw my object. I'm just going to draw a line with an arrow pointing up. I'm just going to mark that as O for object. Okay, then we know that the distance between the object and the mirror is 1 meter, and the law is that the image is always the same distance. Okay, so this will also be 1 meter behind the mirror. Okay, so the question was, how far is the image behind the mirror? And then your answer is 1 meter. If you want to be very fancy, 1 meter behind. Yo, so sorry for the terrible handwriting. behind the mirror. Okay, let's look at the next question. Okay, question 12, triple choice. As you walk toward a plane mirror, does the distance between you and your image increase, decrease, or stay the same? Explain. Okay, so pause the video, try and answer that yourself. Okay, so again, I'd advise you to start by drawing an image, a diagram. Let's say this is the mirror. Here we have the floor. Let's say we start at this position right here. Okay, and then we are moving. We're going to walk closer, and we are going to end up over here. Okay, let's just call this 2 and 1. So we start in position 1, we move to position 2. Then if we were to draw the images, let's use different colors. Okay, so this distance, the image distance when I was in position 1 has to be the same for position 2. Okay, so the image would have been there, and then the image for this one will be closer. Okay, so our answer will be, let's read the question again. As you walk toward a plane mirror, does the distance between you and your image increase, decrease, or stay the same? Okay, so here we have 2, here we have 1. Okay, so in position 1, the distance between myself and my image, sorry for the crooked line, is very far. And then in position 2, the distance between me and my image is a lot shorter. So our answer is decrease. Between you and the, answer is decrease. Then you also have to explain why. So let's quickly look at the explanation. Okay, pause the video and then you can read this answer. By drawing the diagram, it also already shows that you understand what's going on, and then it'll be easier to put it in words. Question 13, diagram. Two plane mirrors meet at right angles. Okay, so there's a mirror that meets at right angles or at 90 degrees. At the origin of a coordinate system, origin is where it's 0, 0, as shown in figure 16.17. Figure 16.17. A long object extends from x equals 1 meter and y equals 1 meter to x equals 4 meters and y equals 2 meters. Okay, so maybe we can ask a question in the exam, probably not, but potentially, where we don't give you the image, where you have to be able to visualize it, but the chances are very small. Okay, so in the exam we'll probably give you like this. We'll give you the image just to visualize it. Then I advise, if the image is too small to draw on, that you just redraw it. Make sure it's large enough to help you answer the question. Okay, so it says here, draw all three of the images formed by the two mirrors. Hence, one of the images, the three images, is due to reflections from both mirrors. Okay, so the first one's not too hard. Let's reflect it in Y. Okay, so I go to where this begins. It's at 1, 1. Okay, so the opposite of 1, 1 is going to be negative 1 on the x side, right? So I have negative 1 here, and it'll still be positive 1 on the y-axis. So I'm going to start there. Let's make a dot. Okay, dot. Dot. Okay, then we can see it ends at 4, 2. So here we have 2. This would have been negative 1, negative 2, negative 3, negative 4. So negative 4 and 2. That's my second dot. And then the line is supposed to go through that point. Okay, there we go. Okay, so that's the first reflection. If we reflect it over here, let's make that a different color. then we go 1 away over here, we'll start there, and 2 blocks away from 4, so 1 2 1 2. So then the image, ooh, that's a little bit skew, it's not so easy to place it. Okay, let me just draw it freehand, but you get the idea. Oh, computer's not working with me. Okay, so that's the second reflection. Now the third one is a little bit tricky. Take any of these images and then reflect it. Okay, so let's take this this red one. We'll draw the reflection in pink. So imagine that this is the mirror, and we're reflecting the image to find the third one. That's just the rule. So study it and then you can apply it. So our first point should be there, and our second point should be there. Okay, so 2 blocks away, 2 blocks away, 1 block away, 1 block away, and we'll have a straight line. Oh, that is so bad. We should have a straight line going from here. Trying to use ruler on my writing tablet. Not working. Let's try again. Oh, okay, you get the idea. Maybe this will help. Not really. So sorry for the interruption. I can't continue unless I've drawn this line. Okay, there we go. It's a little bit better, but you get the idea. Okay, so remember that the third image is going to be a reflection of one of the images as it's said in the hint. Okay, and this is what your final diagram will look like. Okay, next question, question 14. Calculate. You stand 2.3 meters in front of a plane mirror. Your little brother is 1.2 meters in front of you, directly between you and the mirror. What is the distance from you to your brother's image? Okay, so as before, please write down, reference the question that you're doing, write down question 14, sorry. Please draw a diagram to try and visualize what's going on. Pause the video and see if you can solve this question. Alright, okay, so let's start off. Let me draw some straight lines, that it should be nice. Okay, so let's draw our mirror in blue, and then our floor will draw like that. Oh, I'm wasting time. Okay, so here's our diagram. Luckily it does not have to be to scale, just make sure it's large enough. Okay, so the purple represents you, the taller image, object, and these dotted ones are the images. Okay, so I started by just drawing a mirror, drawing a floor so that I can put my objects in line. Then I drew my object, more or less the same distance away. I drew the image of the object. Then I just marked the distance, 2.3, 2.3. I didn't use a ruler or anything, I just mark it roughly like this. Then I drew the object, or the brother arrow here. The arrow represents my brother, 1.2 meters from the mirror, and then the image the same distance. Okay. Then the question asked, what is the distance from you to your brother's image? Okay, so I'm here. This is my brother's image. Okay, so I know that this distance is 2.3, and then from the mirror to the image it's another 1.2. Okay, so the distance from me all the way to my brother's image is going to be equal to 2.3 plus 1.2. 2.3 plus 1.2, and that's going to be equal to 3.3 meters. Okay, question 15. Remember to write down question 15 and draw a diagram. Please read the question, try and solve it yourself, and then you can play the video again to see the answer. Okay, so a nearsighted python with a length of 4 meters. Okay, the python's length 4 meters is stretched out perpendicular to a plane mirror. Admiring its reflected image. If the greatest distance to which the snake can see clearly is 9.6 meters, greatest distance, how close must its head be to the mirror for it to see a clear image of its tail? Okay, so we'll have to start with the diagram. Let me just quickly pause and then I'll put the diagram in. Okay, so here's a diagram. I drew a mirror, I drew a snake, a little tongue and eye there just to indicate what it is. Then I added my distances. Okay, so I knew that the snake is 4 meters, so I added that it's 4 meters long, and it said how close must its head be to the mirror. So I knew that there's a distance, but we don't know what the distance is. So that's why I just left some space and I just labeled that D. We don't know what D is. Okay. Now the approach to this question is as follows. The insight that you need before you can answer this is you should know that 9.6 meters is the total distance that the light travels before it reaches the snake's eye. Okay, so let's say, for example, the snake slightly lifts its tail. I just exaggerated the size. This is supposed to be a dotted line of the snake's tail to represent that it's being lifted. And then we know that light travels in straight lines. So the light travels from the end of the snake to the head of the snake on its way to the mirror. Okay, so pretend that there is no angle. Then how far did the light travel? Okay, it traveled 4 meters because the snake is 4 meters long. That's why that purple arrow is there. Okay, then it travels another distance of D. We don't know what that value is yet. Then from the mirror to the snake's eyes, it travels a distance D again. Okay, so we can then write an equation that says the distance the light travels is going to be 4 meters plus D plus D. Okay, so this underlined is the 4 meters plus the distance D, that's to the mirror, and then from the mirror is the other plus D. And that equals to 9.6 meters, okay, because that's the maximum distance the snake can see clearly at. Then we simply solve for D. So step by step, what do? We take the 4 across. Okay, so what's the opposite of plus is minus. Okay, so when we take the 4 across, we get 9.6 minus 4. We still have D plus D, which is going to be 2D. Okay, it gives me 5.6 when I calculate that. Then if I divide both sides by 2, I end up with D on the left and I end up with 2.8 on the right. And that's my final answer. Okay, so the head must be 2.8 meters from the mirror. Okay, great. Last question and then the explanation of wavefronts. Question 16. Calculate. 2 plane mirrors are placed with an angle of 60 degrees between them, as shown in figure 16.18. A horizontal ray of light strikes the slanted mirror. After the ray reflects from both mirrors, what angle theta does it make with the horizontal? Okay. Please write down question 16. Please redraw this diagram large enough so that you can fill in angles everywhere, and try this question before you play the video to see the answer. Okay, great. So I hope that you drew the setup. I'm just going to slightly extend this line. Okay, so that they're all crossing. Okay, so we start off with this ray right here. Okay, 2 plane mirrors placed at 60 degrees, so that's what that 60 represents over here, and a horizontal ray of light. Okay, so this horizontal ray of light means we have a light coming in like that. Okay. Okay, so now we want to find theta. Alright, so we know that this is 60 degrees. Okay, we know that the sum of the angles inside a triangle is 180. Okay, and when this is 60, how can I explain this? The short way is just to know that this is an equilateral triangle, which means that all sides are equal to 60. If you really wanted to, we could explain it with using the normal. Okay, so this angle has to be equal to that angle has to be equal to that angle, but in short, I know that explanation didn't really help. When this happens, so if you get a question like this, just know that an equilateral triangle is formed. Okay, so then this angle is going to be 60, that angle is going to be 60, that angle is going to be 60, and then this triangle here, the total sum will be 180. Okay, so let me just draw another normal in pink over here. Okay, let's say this will be our angle of incidence, and this will be our angle of reflection, there and there. Okay, so if we know that this angle is 60, immediately we actually already know that this angle is also going to be 60. Why? Because these two add up to 90, those two add up to 90. If this is 60, this has to be 30. This is equal to this one, so this will also be 30. 90 minus 30 will give me 60. So theta is 60, and that is our final answer. Okay, so theta is equal to 60 degrees. When you draw the diagram and you show how you calculate the angles, that's like showing the steps on how you solved it. It shows me that you understand what you're doing, that you didn't just copy the answer from somebody else, and then you can get a mark for that. Okay, so please draw the diagrams when you write a test or an exam. So lastly, wavefronts. I don't think we're going to ask you any questions on this, but just so that you know, a wavefront is like the edge of outgoing waves. So let's say we've got a light bulb in this point here, and we want to draw the direction in which the waves are going. We can draw it as rays, as a straight line, and the ray shows me in which direction the light is moving. The wavefront shows me in circles how the light is dispersing. Okay, so this circle represents the edge of how far the light has moved. I don't know, a potential question we could ask you is probably, let's just zoom into this picture here. What is the angle between a wavefront and a ray? And that is always 90 degrees. Okay, so just know that that they're at 90 degrees. I really don't think we'll ask you any other questions. Okay, so that's it for this lesson.